Hello, welcome to IBCC channel. In this video, I will demonstrate how to use a router's link state database to check the link states advertisement. In previous video, we talked about the link states advertisement in details. I put the link in below descriptions. If you're interested, you can take a look. In this video, I will use this GNS3, the routers shown like this diagram, to illustrate how to check the link states from the LSDB of the router. So first, a brief talk about this topology. So in this diagram, there have the three areas: area 0 plus area 5. Area 5 is a standard area. Area 7 is not so stable area. So there, from the left-hand side, there is a external network connect to this R1. In the right-hand side, there is another external network connect to R5. So external network is redistributed into the OSPF from R1. On the right-hand side, this external network is redistributed to the OSPF from R5. Okay, let's start. So let's first log into the R1. Yeah. Okay, so we are in the R1. Okay, let's do the show IP OSPF database. Let's put the long name here. Press enter. You can see the database here. So from the R1, here's a high-level description of the database. Describe the LSA for the area 5. You can see the first paragraph is router link states the area 5. So they are categorized by the LSA types. So first, you remember this, right? I just put this diagram to here to quickly show you here. So you know that each LSA's name. Type 1 name is router's LSA. Type 2 is network LSA. Type 3 is summary LSA. Type 4 is ASBR summary LSA. Type 5 external LSA. Type 7 is NSSA external LSA. Just remember the name here. You can compare to the LSDB. Okay, let's log into the router R1. Yeah, here's router R1. We do the show IP OSPF database here. See, you can see the R1's OSPF LSDB here. LSDB lists all the link states advertisement. This output is a high-level indicator of each of the link states advertisement. So R1's link database statement only include the area R5. Here you can see the area R5 here. So since R1 only belong to the area 5, so if you know each type's name, you will know what this means. So the first route link states means type 1. The net link states means type 2. The summary net link states is type 3. And the summary ASB link states is type 4. And here's type 5. Type 5 called the AS external link states. So okay, I can put this name here. You can take a look. So each type's name here. Type 1 is called the router LSA. Type 2 called the network LSA. Type 3 is summary LSA. Type 4 is ASBR summary LSA. Type 5 external LSA. Type 7 is NSSA external LSA. So this list is a high-level descriptions. Okay, let's first take a look at type 1. So type 1 called the router link states. In this output, you can see there's 3 routers send the type 1 LSA in. So the first router is 1.1.1.1. That's router 1's router ID. The second is 10.255.255.2. This is R2's links ID. Third one is 10.255.255.3. This is R3's router ID. So also they have advertise router. So who advertise this link states advertisement? So that's their list here. Advertise router is just like this. So from here, you don't see much information about the link states LSA. If you want to see the detailed information, you use this command. So I use a Cisco router as demonstrations. Maybe the different platform have a different command, but here I use a Cisco router. So you do the show IP OSPF database. So you can question mark. You see there is an option called router, right? Type router. See here when you enter, you see the detailed information. Take a look at the first one. So first one is the router link status. This is a type 1 in area 5. So first link states advertised route LSA is this much longer here. So from this you can see link ID, who advertised this LSA, this router link LSA. So that's come from 1.1.1.1. So advertising router is same 1.1.1. And in this router link LSA, they include 3 links here. So the first link is 10.255.255.255.1. This is R1's loopback interface. Okay, this loopback interface participated in the OSPF. So the second link is called connected, right? So the link is here has a link ID is 10.5.0.3, and the router interface address is 10.5.0.2. So the router IP address is .2. .2 is R1's interface G0/1's IP address. Since this is a broadcast network, so the link ID is designated router address. Designated router address is this one, R3's IP address in this broadcast network. So this is .3. Just like this. There's another link. Okay, another link same is you see the router interface address is 10.5.0.0. That is R1's interface G0/0, right? Same concept applied to the designated router. IP address. Designated router IP address is 10.5.0.1. That's the R2's IP address on this specifically broadcast network. So that's DR. So that's one of the LSA, one of the router type 1 router link states LSA advertised from the R1 is first he have to present himself, use a link ID, present himself, right? Under this link ID, they have to list all the link which participate in the OSPF, just here. So this is how you look the router link states. If you like, you can see the next router state. The next router state is this. So now you can see clearly this router link states ID is 10.255.255.2. That is R2. That's the R2's ID. R2's ID in this area 5. Advertising router is R2 also. And in the R2, we include two links. Why include two links? Since these two links belong to the area 5, right? The first link is router interface is 10.5.0.4. 10.5.0.4 is here. Is interface G0/1 of the R2. Another interface IP address is 10.5.0.0.1. That is here. That is interface G0/0 of the R2. Since these two interfaces here belong to area 5, no other interface on R2 belong to area 5 except these two. So here list the two interfaces. Yeah. This is how you look at the type 1. Okay. Let's take the type 2. Type 2, if you want to look at type 2 routers, just first take a look at the high-level description here. Do the show IP OSPF database. You see the type 2. Type 2 is acronym as a net link. Basically, full name is a network link states here, right? So in the router, you just in short put the net link states, right? Here are the 3 net link states from the 3 different routers here, right? So one come from the .1, 10.5.0.1 is one come from this here. Another come from 10.5.0.3. Another come from this. This is from R3 regarding the multi-access network between the R3 to R1. The third one is come from the 10.5.0.5. Okay, so this is here. It's R3. It's here. This is regarding the multi-access network between the R3 to the R2. So that's the three network link states here. This is just the high-level information here. If you want to see the details, okay, you can do this command. Okay, do the show IPOS database. Then you put the question mark. You see here. There give you the options. It's called the network, right? You do the network. You do network. Okay, here give you the details. What do you want to see? Okay, so the first take a look at the first IIC. So this first type 2 IIC is not long, it's short. Since type 2 is only regarding which router connect to a specific multi-access network. So the first type 2 IIC is come from the link ID is 10.5.0.1. Right, 10.5.0.1 is here. It's G0/0 interface of the R2, right? So who advertises this, right? It's DR advertises this one. So advertised router is 10.255.255.2 is also R2. R2 is a DR for this specific network. So the R2 advertises this type 2 LIC. So what the type 2 LIC information is? So the information just told you which two routers are attached to this specific network. So he told you there are two routers attached. One is R2, another is R1. So let me show you here. So in this diagram, there is a specifically multi-access network between the R1 and R2, this link, right? So there's two routers attached on this specific link. So this is what the type 2 try to tell, right? If you like, take a look at next type 2 link states, network link states. So this is advertised by, so link ID is 10.5.0.3. That is R3's interface G0/0. advertising router is 10.255.255.3. This is R3 here, R3 here. So advertising router is R3. So R3 is DR. So what is the information in this network link states? Just two routers attached. So one router is R3, another R1. They told the story is in this specific network here, right? In this specific network here, there's two routers attached on that. One is R3, another is R1. That is pretty much the type 2 told us. So, okay, let's move on to the type 3. Okay. Type 3, you take a look at this network. See, you see the type 3, but all this type 3 is learned from the all this type 3 is inject into this area 5 from R2, right? Is regarding the different other other areas information. So if you want to see how the type 1 routes in the area 5 to become the type 3 and propagate out, the best place to see is in the R2, right? So okay, let's log into the R2. Show IP OSPF database. So when you show IP OS database, you see that this database looks longer than the R1's database, right? Why is it longer? Because R2 is ABR, so it must contain the area information which they attached on. So the R2 connect two areas. One is area 5, another area 0. So they must contain the area 5's link LSA and area 0's link LSA. So from this output you can see the first several paragraph is regarding the area 0. You see area 0 here, area 0 here, area 0 here, right? Until here as area 0's LSA. Then next you can see the area 5. All from here down below is area 5. So from here you can see the area 5. You compare one thing I just mentioned here. Compare area 5 link database with R1's area 5's link database. It's from here. Yeah. You see this? Let me pull this. Okay, let me detach it. Let me detach it to see. You see here, there's a database here, and database other side is identical. So that means the link database regarding the same area should be synchronized, should be exactly the same. So I just want to show you here. Okay, let's back to the link states here. So from here we see we want to see the what do we want to see? We want to see the area 5's type 1 routes propagate to the R2. Then R2 generate the summary routes based on the area 1 and send out to the area 0. So that means area 0 will receive the type 3 regarding the area 5's, right? So let's do this. See, let's take a look at the area 0 summary routes, right? Area 0 summary routes here. You see the name is summary net link states. Net means network, so the full name should be the summary of the network link states. Yeah. So you see how many routers? 1, 2, 3, 4, 5, 6. Okay, so there's how many items here? 1, 2, 3, 4, 5, 6, 7. Okay, seven item here. So 7 item here. Why 7 item, right? So actually 7 items is, you see the link ID is 10.5.0.0 is a link here between the R1 to R2. The second is for 10.5.0.2. This is the link between R1 to R3. The third one is 10.5.0.4. This is a link between the R3 and R2. And also here is a 10.25.25.1. This is loopback address of R1. Okay, 255.255.255.3 is loopback of the R3. Other ones 10.255.255.5. 255.255.5 is what? It's R5. Okay, here's R5. Okay, so this two. Okay, this two is not regarding the area 5 summary. This is regarding the area 7 summary. So let's remember, the area 7 does the same thing as the area 5. They inject some routers regarding the area 5 into the area 0. So area 0 also receive the summary from the area 7. Also, this network is from area 7 also. So we don't look at that. So only these three network plus these two, totally 5 networks is regarding the areas 5's information. Yeah, this is a summary routes. So this regarding the links of the area 5's, right? You can clearly see this regarding each links of the area 5. Okay, so you can see this difference with this is a format is different with the type 1. Type 1 is one routers present all its links to the areas, right? And so the summary routers is just take the type 1's information and redo it is categorized by each of the links and put here. So if you want to see the detail of the summary network link states, you can do this, right? So show IP OSPF database and do the summary, right? Summary can see details. Here I give you detailed information. So take a look at the first one. Summary links is no longer is just contains a mask, right? Network mask. It contains a network mask and the network. Basically, network is just a network the link states ID. So that's why they call summary, because they remove all the detailed information from the type 1. They just leave the network mask and the network. Yeah, network is link states ID here. Right, they send this out. So you can see next is it's the same concept, right? You just have a link states ID. Link states ID is just as a network, a network mask, and plus a metric. That's all. So this is a summary routes, right? This summary routes regarding the information of the area 5. If you like, you can see. If you like, you can see the other summary routes regarding the come from the area 7. Yeah. Okay, so let's move to the next. Okay, next we call the type 4. Type 4 is called the ASBR summary. Let's do this. Type 4 concept is a little bit tricky. You need to get better understand that. So let's also take a look. So recall what's a type 4 regarding. So type 4 is this routes, right? When type 5 advertise external routes. So type 5 leave ASBR's route ID as a source. Then generate type 5 out. When the type 5 propagate to the R2, then propagate to the area 0, then propagate to the other standard areas. So all this information regarding the ASBR, which the external routes generated, that information was missing because that information is router ID. Router ID is type 1. Type 1 is not flood out to the other areas. So other routers have to know that ASBR's router ID. So if don't know that router ID, they will cannot build his shortest path tree. So that is type 4 come in play. So type 4 is will advertise the ASBR's router ID as a type 4 out to the other areas. So here's type 4 here. Type 4 here. You can see type 4. Just the data ID here. Link ID is 1.1.1.1. That's R1. This R1 is ASBR because it connects to external network and do the redistribute. So advertise router, who is advertised this are type 4. Type 4 is advertised by the ABR. So advertised router is R2. R2 advertised. What's this? So take a look at details. So it gives an ASBR summary. Into this one, see the details. Yeah, from the output, you can see the this one. This is a type 4. Type 4 or type 4 link RIC regarding the R5's R1 in R5's router ID. Here you see the link state ID is 1.1.1.1. This is they note this one as AS boundary router address, right? So this is R1. That's it. Only this information. And the advertising router, you can see advertising by R2. So why the R2? Because R2 generated this type 4 route. So advertising router is R2. So plus a matrix, right? So that's it. Type 4s only have this information, mainly just regarding the link states ID, right? So okay, let's take a look at the type 5. I just do this. Type 5. So actually, we do the type 5. We can back to the R1 to do type 5, because since R1 have less information, right? Since type 5 generates from R1, then propagate to the area and from the boundary area boundary router and send out, right? So from R1 have less information. You can do this, show IP OSPF router. You can see the type 5. Here listed two type 5. Why two type 5 here? So first, the type 5 is the type 5 generated from right-hand side regarding network 172.16.51.0. This type 5 is generated by the R1. Another type 5 is this, is 117.16.71.0. That is the right-hand side here. This external network is redistributed into the not so stable area, then propagate all the way back to this standard area, area 5. Okay. So if you want to see the details, here is a way to see this. See the show IP OSPF database, you see the external. So external, you can see the details, right? So then I'll show you two external. What do we want to look is want to look at this the first one, right? This one. The first one, link ID. Link ID is external networks, and advertising router. Advertising router is 1.1.0 is R1, right? So what is it regarding for? The regarding the just external routes, right? Here is a forwarding address here. Forwarding address here is metric. Matrix 20 is by default in the Cisco router. What is forwarding address? So forwarding address means actually where to forward this package if they forward to this network, right? So if this is 000, that means this forwarding address the same as advertising router, right? Same as advertising router. So if this is different, you can see bottom here is different, right? So you see the bottom, another LSC is here is a little bit concept, a little bit complex. I just quickly explain here. So either regarding the network 172.16.71.0, this is an external link ID, right? So this external link ID is connect to the non-so-stable area. So if you redistribute this one to the OSPF, there will become the so R5 should be advertising this external routes. Yes, that's correct. So but since this area is not so stable area, so R5 is generated type 7 regarding this external network. So this external network as a type 7 sent to the R4. R4 is ABR. ABR is regenerate this external routes, change the type to type 5, then propagate it out. So since this, you can see, so the advertising router from the we are in the R1. From R1's perspective, is R4. R4 is advertising router. So since R4 really generates this LSA type 5, not R5. R5 in this case is generated type 7. So advertising router is R4 here, is 10.25.25.4. So actually the OSPF also smart to know, okay, actually who you want to forward the traffic, you need to forward to .5, right? The 10.255.25.5. So why? Because eventually the traffic should go to 5. So not go to 4. So you can directly forward traffic to the 5 instead go forward the traffic to the 255.25.4. This is the case. The forwarding address and advertising route is different, right? So this for this case. Yeah, let me explain the last concept of the type 4, right? Type 4, you see, you back to this advertisement. This is a type 5. Type 5 is advertising router is 1.1.1.1, right? So this one will be propagated out to all over the place, right? Because type 5. Let's take a look. R6. Show IP OSPF database. I see the external routes. Yes, right? You do the show OSPF external routes. External routes. See, in the R6, right? They learn this external routes. No, sorry, I should say they learn this LSA, type 5 LSA. So advertising router is 0.0.00. So the forwarding address advertising router is 1.1.1.1. that was R1. So forwarding address is 0.00.0. That means the next hop should be pointing to the 1.1.1.1. So for this R6, they need to know, to build his shortest path tree, they need to know what is 1.1.1.1. So that is the type 4 come in play. So you take a look at this R6 routing tables. Where is this regarding the link ID 1.1.1? Only in here, only in the summary ASBR you can find this link ID. So go to the, if you want to go this link ID, you must go to the 10.5.5.2, right? Just need to go to R2. So this information plus the information this, the R6 can build is the shortest path tree that figure out how the route is. So if you're missing this type 4 here, then that's the problem. Then it cannot work this way. Okay, so last one, we just quickly show you what is a type 7. So type 7 we have to go to here, right? Type 7 we need to go to the either R4 or either R5. Let's go to the R5, take a look. So IP OSPF database. Type 7, here's, you see, there's type 7. Type 7 address, one's default, so I generate default for that. Another is here, another is external routes, 172.16.71.0. This external routes is redistributed into the OSPF. So we take a look at this. This is type 7, right? Oh, goes. So how to see the type 7 in question mark in the system router give you the option to see this. It's called this. You do this. You do the show IP OSPF database. And SSA means not so static areas. External. See here, give you the information. Type 7. Type 7 is pretty much. Take a look at the second one. Okay. Type 7, the format is pretty much like the type 5, but just call the type 7. You can take a look. So link states ID and advertisement router is 5. ID is network, external network ID. Forwarding route, here forwarding route and the advertising router is the same here. Okay, just list here. So this all I show you how you, in the system router how to check the link states advertisement in the link states database. This is very useful into the OSPF troubleshooting. For first use case is if, let's say, if you have some misconfigurations, you have some duplex subnet. Okay, let's for example one duplex network on the R1. So same network you configure to R4, right? For example, you configure, let's say 192.168.0.0/24 on this, and also you configure same on the 192.168.1.0 on the router 4. So in a small network, it's easy to troubleshoot. But imagine there is 100 routers run OSPF. How you find the duplex networks, right? It's really hard to find. Right? So to fix that, you just need to log into to only routers, because in the same areas, the OSPF, the link state database is synchronized. So you log into that, you do that, you show the link state database, and if you formula with the route type, you just show the type and do the match. Let's see, you just show this one external. You want to match something, you want to match. Let's see, you do the match, right? Do the section, something like this, right? You do that just. section. So that's give you where the information is. You can quickly find out the duplicated IP address, right? Another sense, check this, right? Another use case is if you are redundant the link, right? For example, like this, from R2 to R4, you have redundant link. If you show the IP routes for IP routes, right? They only show you, they only show you one links, right? Because let's say you want the just one routes show up. For example, you want to see how to go to this network 10.7.0.0, right? 10.7.0.0. Okay, that's not. I need to go to R2. R2 to show this. Show IP route. Show IP route. You see, here is only one. When show IP route, only one path come up, right? However, you have a redundancy link. You don't know the second pass is good or not good. You have many ways to check the second pass is good or bad. But one thing, just from routing database perspective, you show IP OSPF database, right? Database, you see you can see from here database. You can also figure out those two paths is existing or not. So that's all. We can. I think we can end this video for now. If you find this video helpful, please give a thumb up. Thank you for watching.